Hello everyone. So yesterday we started with chapter 3, that is electric current. In the other lecture we studied about what is electric current and what is meant by potential difference. Now today we are moving on to the next topic, that is Ohm's law. Now what is Ohm's law? It is basically a relationship between I and V. Okay, so we will revise first. What do you mean by I? What is V, etc. What is I? I is current. What is V? V is potential difference. What is W? Work done. Q? Charge. Okay, we had studied two equations. V is equal to W upon Q and I is equal to Q upon T. Okay, I is equal to Q upon T and V is equal to W upon Q. V stand for potential difference, W stand for work done, Q stand for charge, I stand for current, okay, and T stand for time. What is the unit of potential difference? The unit of potential difference is volt. Unit of work done is joule. Unit of charge is coulomb. And unit of current is ampere. Okay, this we had studied in the other lecture. Now this is Ohm's law. What is Ohm's law? If the physical state of the conductor remains constant, the current flowing through it is directly proportional to the potential difference V between its two ends. While you write the definition, the statement of any law, you have to write the same statement which is there in the textbook. Okay, try to learn it and write it as it is. So what is Ohm's law? Basically it is a relationship between I and V. What is I? I is current, V is potential difference. If the physical state of the conductor, physical state of the conductor means its temperature, its length, its material, etc. Okay, so there is a wire. Okay, as long as you are not changing the material of the wire, the length of the wire, okay, the current I flowing through it is directly proportional to the potential difference between its ends. Okay, so basically you have to remember that I is proportional to V. I is proportional to V, or I is equal to kV, where K stand for constant of proportionality. Whenever you convert this symbol, that is directly proportional, into equal to, here directly proportional is converted into equal to. When you convert that, you have to put a constant. Here the constant which is put is K, that is constant of proportionality. So I into 1 upon K. If you take this K towards the left hand side, it will become the denominator. So it will be I into 1 upon K is equal to V, where 1 upon K is equal to R. Okay, that constant is given a name. The constant is given a name, that is resistance of the conductor. Sorry, so 1 upon K is equal to R, that is the resistance of the conductor. So instead of 1 upon K, they have written R, so the equation becomes I into R is equal to V. So what is Ohm's law? Ohm's law states that I is proportional to V. You may learn it from that statement. Okay, I is proportional to V. What is I is? What is I? I is current. What is V? V is potential difference. So what is the law? If the physical state of the conductor remains constant, the current I flowing through it is directly proportional to the potential difference. So this much is basically the law. The current flowing is directly proportional to the potential difference. To that you have to add this statement, if the physical state remains constant. Now what do you mean by physical state? It is there on page number 34. In a box they have written physical state of a conductor means length, area of cross section, temperature and the material with which it is made up of. Okay, so the length, the area, the temperature and the material of which the conductor is made up of. So if you are taking a copper wire, another wire, if you take another wire which is also made up of copper and they are of the same length, okay, they are of the same length, same area of cross section and same temperature, then I is proportional to V. What is I? It is the current flowing through the conductor, and what is V? It is the potential difference across its two ends. So what is Ohm's law? I repeat, if the physical state of the conductor remains constant, the current I flowing through it is directly proportional to the potential difference V between its two ends. Okay, you have to write the complete statement if you are having a question. I is proportional to V. So I is equal to KV, where K is the constant of proportionality. I into 1 upon K is equal to V. 1 upon K, we are taking it as R. R means resistance of the conductor. So instead of 1 upon K, we have written R. So the equation becomes I into R equal to V. Hence V is equal to IR, or R is equal to V plus I. This is known as Ohm's law. If you are having a question on state and derive Ohm's law, you have to write from here till here. Even if you write this, you will get marks. Okay. Now, what is the unit of V? The unit of V is volt. What is the unit of I? The unit of I is ampere. Now, there is a unit for R. The unit for R is ohm. Okay, the unit of R is ohm and it is denoted like this. Okay, this is known as omega. Okay, this is ohm. Okay, what is ohm? It is the unit of R. So 1 ohm is equal to 1 volt upon 1 ampere. 1 ohm is equal to 1 volt upon 1 ampere. So how will you define 1 ohm? If 1 ampere current flows through a conductor, when 1 volt potential difference is applied between its ends, then the resistance of the conductor is 1 ohm. I had earlier told you how to learn a definition. While learning the definition, first learn the equation first. First learn the formula. When you learn the formula, from that formula you can make the definition. Okay, but the statement should be according to the textbook. That is the condition. So 1 ohm is equal to 1 volt upon 1 ampere. So what is 1 ohm? You may see here 1 ohm is equal to 1 volt upon 1 ampere. So if 1 ampere current flows through a conductor and 1 volt potential difference is applied across its ends, then the resistance of the conductor is 1 ohm. Okay. Now we may move on to the next topic, that is resistivity. Now basically, what is resistance? The dictionary meaning of resistance means to resist something, to go against something. Now we studied that. Consider this is a conductor. In the other lecture I had explained a conductor has free electrons. Okay, here I have shown free electrons. These are free electrons. Besides free electrons, there are ions and atoms. Ions and atoms. When it is connected to a positive terminal and a negative terminal, then the electrons will move towards the positive terminal. The electrons will start moving towards the positive terminal. Only the electrons. Okay. So when the electrons move, you may see the atoms and ions are sitting in their way. Okay, they are present in their way. So they will collide with them, producing a resistance. That is what is called as resistance of a conductor. Every conductor has resistance. Basically, what is a conductor? Conductor is a material which allows the current to pass through it. Okay, the current is passing through it, but while the current is passing, there is resistance in the conductor in plus or minus amounts. That means in increased or decreased amounts. In some conductor it might be more, some conductor it will be less. Okay, so this is what is called as resistance. You may mark this much on page number 34. Now we may move on to the next topic, that is resistivity. What is resistivity? Resistivity is the property of a material, okay, of 1 meter wire and 1 meter square area wire. There are different materials like copper wire, silver wire, aluminum wire. Okay, so the wire could be of different materials. So there is a standardized value for each and every material. That standardized value is called as resistivity. How to derive the equation for resistivity? It is a 3-mark question. On page number 34, towards the last paragraph, at a given temperature, let R be the resistance of the conductor, L be the length of the conductor, and A be the area of cross section of the conductor. Okay, then R is proportional to L. That means R is proportional to L means as the length of the conductor increases, the resistance also increases. R is proportional to 1 upon A. That means R is inversely proportional to A. That means as A increases, R decreases. I repeat, R is proportional to L means as L increases, R also increases. R is inversely proportional to A means as A increases, R decreases. Okay, that means if you increase the thickness of the wire, the resistance will decrease. If you increase the length of the wire, the resistance also will increase. Okay, so if you combine these two equations, you will get R is proportional to L upon A. R is proportional to L upon A, or R is equal to rho. Okay, it is written as rho. It is RHO, rho. Okay, it is written like this. Rho. It is the constant. Okay, that constant into L upon A. So I told you that when you convert this proportionality into equal to, you have to put a constant. Here the constant is rho, and that is constant of proportionality. And what is rho? Rho is the resistivity of the conductor. Okay, so this much you have to write. You have to write till R is equal to rho into L upon A, where R stands for resistance, rho stands for resistivity, L stands for length of the conductor, and A stands for area of cross section of the conductor. Okay, on page number 35, there is a box given resistivity of some materials. That is important. It could be asked as MCQ questions, multiple choice questions. Generally, the resistivity of copper is asked. It is 1.7 into 10 raised to minus 8 ohm meter. Nichrome, it is 1.1 into 10 raised to minus 6 ohm meter. Diamond, it is 1.62 into 10 raised to 13 to 1.62 into 10 raised to 18 ohm meter. Okay, it could be asked as MCQ questions. Now here you might have noted that the unit of resistivity is ohm meter. Above that box there is a question. How will you prove that the unit of resistivity is ohm meter? Now I'll show you the answer for that. You know that R is equal to rho into L upon A. So what will be rho is equal to R A upon L. Cross multiplying, rho will be equal to R A upon L. What is the unit of R? It is ohm. Unit of R is ohm. I had discussed it. Unit of R is ohm. Unit of area is meter square. Okay, side into side, that is meter square. Wire is a circle, still the unit of area is meter square, SI unit, and the length is meter. Okay, so this M and this M1 M will get cancelled and the equation will become ohm meter. Therefore, the unit of resistivity is ohm meter. Okay, so this is about resistivity. Now we may move on to the next topic, that is electric circuit. We know what is an electric circuit. We had studied in our 8th standard also, isn't it? So what is electric circuit? Electric circuit is a pathway through which a current flows. Okay, so here this is the diagram of an electric circuit. Okay, in the diagram of an electric circuit, I will explain what are the parts of an electric circuit. This is the cell. Okay, this is the cell. Okay, this is the key. That means switch. Okay, key or switch. This red colored which I have shown, that is the wire. It is the conducting wire. This R which is shown is the resistance. Okay, we have connected a resistance. Now through this they have connected a voltmeter. This is a voltmeter. This is a voltmeter. You may see that the voltmeter is not connected in series. Now what do you mean by series? One after the other. You may see here, from here till here, from here, then here, then here, till here. It is in series, in continuation. But what is in the case of voltmeter? It is a connection in between, a joint in between. That is said to be a parallel connection. So voltmeter is connected in parallel and this is said to be an ammeter. Okay, it is an ammeter. Ammeter is connected in series. So ammeter is connected in series and voltmeter is connected in parallel. So these are the symbols which are used to draw an electric circuit. And what are the components of an electric circuit? Key, cell, wire, resistance, voltmeter, ammeter. These are the components of an electric circuit. Okay, this much you may understand. Now page number 35, there is a question. Observe. You have to point out the mistakes in the figure above. There are some mistakes in those diagrams. What are the mistakes? We will see. The first diagram, okay, the bulb is shown to be glowing even if the circuit is not complete. It is broken. Okay, so what is the mistake? The bulb is glowing even if the circuit is not complete. Second, the bulb is shown to be glowing even if the circuit is not complete. It is not connected to the negative terminal. Okay, you know the positive and negative terminal of a cell. Okay, so it is not connected to the negative terminal. That means the current will not flow, but still the bulb is shown to be glowing. That is a mistake. Third one, even though they are connected, the circuit is complete, the bulb is not glowing. In the third diagram, even though the circuit is complete, the bulb is not glowing. In the fourth one, there is a piece of rubber in between, and rubber is a poor conductor of electricity. So if you are connecting a poor conductor of electricity in between, the current will not flow. Okay, the current will not flow, but still the bulb is shown to be glowing. So that is the mistake. I repeat, in the first case the circuit is not complete but still the bulb is glowing. Second, circuit is not complete, still the bulb is glowing. Third, circuit is complete but the bulb is not glowing. Fourth, rubber does not conduct electricity but the bulb is shown to be glowing. These are the mistakes which are shown in those diagrams. Now the next diagrams. Why are the bulbs in figures B, C and D below not lighting up? In B, you may see the circuit. The circuit is broken because the wires are broken. They are not joined. So, as the circuit is incomplete, the bulb is not glowing. In C also, as the circuit is incomplete, the bulb is not glowing. In D, you may see it is connected to one terminal. Both the wires are connected to the positive terminal. So I had told you earlier also, for the current to flow there should be a high potential and a low potential. So if you are connecting both to the high potential or the positive terminal which is said to be at a high potential, then the current will not flow because there is no potential difference. Okay, so in the first diagram, that is B, circuit is incomplete. C, circuit is incomplete. D, both are connected to the same terminals, hence the circuit is not complete, so the bulb is not glowing. Okay, so these are the answers. You may write those answers in your textbook. These questions are asked. Okay, now we may move on to the next table on the next page. Now this is the table given on page number 36. These are the components of a circuit and the symbols of the circuit. In the table they have given the symbols of the circuit and its uses. Okay, so the first one is, I will tell you the symbols first, then we will move on to the uses. So first is electric cell. This is how an electric cell is shown. A longer line and a smaller line, a longer line and a smaller line. The longer line shows the positive terminal and the shorter line shows the negative terminal. Battery, it is a set of cells joined one after the other. So this is one cell, this is another cell, this is third cell. So here there are three cells joined one after the other, that is said to be a battery. Open tap key or plug key. This is open tap key, that means the switch is off. The switch is off, the current is not flowing. Closed tap key or plug key. There is a dot in between. This is the closed tap key or plug key. That means the switch is on, the current is flowing. These are the connecting wires. This is how the connecting wires are shown with the help of a single line. Crossing wires, it is one over the other. If this is one wire and this is another wire which are lying one over the other, it is shown by this. Okay, they are lying one over the other. Light bulb, this bulb is not glowing, this bulb is glowing. Resistance, this is how a resistance is shown. Variable resistance means we can change the resistance in the circuit. This is having a particular value, consider 5 ohms. Okay, in this case we can change the value 5 ohm, 3 ohm, 2 ohm. It is a device in which we can change the resistance. So it is variable resistance. Ammeter, it is a device which is used to measure the current. It is connected in parallel. This is how an ammeter is shown. And this is how a voltmeter is shown. Okay, a voltmeter is an instrument to measure the potential difference. Now we will see the table on page number 36. You may take your textbooks. The table is symbols for components of an electric circuit and their uses. Electric cell, you may see the picture. Symbol. Use, to apply a potential difference between two ends of a conductor. So what is the purpose of a cell? It is to apply a potential difference between the two ends of a conductor. If you need more potential difference, then you may connect 2 or more cells. Okay, that is what is called as a battery. So what next is battery? It is a collection of number of cells. What is the use? To apply a larger potential difference between two ends of a conductor. Third one, open tap key or plug key. It is to stop the flow of current flowing in a circuit by disconnecting two ends of the wire. That means the switch is off. Closed tap key or plug key. It is to start the flow of current in a circuit by connecting two ends of the wires. That means the switch is on. Crossing wires. to show wires which cross but they are not connected. Okay. Now next, light bulb. To test the flow of electricity. Lighted means current is flowing. Unlighted means current is not flowing. Next is resistance, to control the flow of current in the circuit. If you need less current, you may add more resistors. If you need more current, you may connect less resistors. Variable resistance, it is to change the resistance as required and thereby control the current. Next is ammeter. It is to measure the current flowing in the circuit. Voltmeter, it is to measure the potential difference flowing in the circuit. Now this table along with the uses you have to write today in your notebooks. Now next I will give you the homework. Now this is the homework. State and derive Ohm's law. Derive an equation for resistivity. For Ohm's law you may write what I had written on the board. That will be enough. Okay, but you have to write the complete sentence. Derive an equation for resistivity. You have to start from paragraph on page number 34 till R is equal to rho L upon A and is called the resistivity of the material. Till there you have to write. Draw the diagram of an electric circuit. It is figure 3.5. What is the unit of resistivity? Derive. It is the question. Think about question on page number 35. I had solved it and shown. Okay, you may write this in your notebook also, in your textbook also, and draw the table showing symbols and uses of various components in the circuit. You have to learn the uses and the symbols of various components in the circuit. The question which will be asked is, they will give you the name of the components and they will ask you the uses or the symbols, or in the form of a match the following question. Okay, so you may go through it today itself and get thorough with it. Okay, thank you.